Hello. Good afternoon, Professor and everyone. This is Team 2 presentation. Our team subject is sorting with dataset countries of the world. The content of the presentation is as follows. First, I introduce about the objective of the project and preview the code. And then we take a look about the sorting algorithm we used. After that, each algorithm is compared and analyzed. Okay, let's get started. The objectives of the program are sorting. Why do we need sorting? Data sorting is any process that involves arranging the data into some meaningful order to make it easier to understand, analyze, or visualize. When working with research data, sorting is a common method used for visualizing data in a form that makes it easier to comprehend the story the data is telling. And by this project, we would like to show how easy it would be to see the data after using sorting algorithms. Then, which sorting algorithm should we use? For sorting problems, many algorithms are used, such as quicksort, insertion sort, bubble sort, etc. We will be using a total of 7 sorts in our project as you see. Since they are applied various methods while solving the problem, the efficiency in terms of time and performance can be different depending on the size of the dataset and the big old complexity of each algorithm method. At the end of the project, we would like to show you the comparison of the algorithms to see which one any of you can use. Now, let's take a look at the code we have constructed. First of all, this is the dataset we used. We used data called countries of the world and sorted using population and area among them. We read the Excel file using pandas that optimized for data analysis and imported the Gauss function from the random class. After that, we made a list and entered population and area. This is an example to show the overall code procession. The code procession for each sorting will be explained in more detail later. By importing NumPy, which expresses data in an array form, the mean and standard of the extracted data were calculated. After that, mean and standard were added as values for each range, and the runtime was calculated through the time function. Finally, for the ranges calculated above, numerical values were visualized as graph using pyplot. In the graph, the x-axis is the dataset and the y-axis is time. Now, I will explain each code in detail and explain code procession and big O notation. First of all, quicksort. Quicksort is an algorithm that uses 3 main steps. Sorts the list by selecting an element called a pivot and moving smaller or larger elements. Thus, the worst-case running time of quicksort is O(n) squared. Second, insertion sort is an algorithm that removes an element from a list and inserts it into its original position. It performs the worst case under O(n) squared. Third, bubble sort is an algorithm that steps through the list, compares, and replaces pairs of adjacent elements. It has worst case of time complexity of O(n) squared. Share sort splits the original list into sublists and uses insertion sort to sort them. Its worst case time complexity is O(n) log n. Heap sort is a comparison-based technique that finds and places the maximum elements. Has a worst case of time complexity of O(n) log n. Radix sort is a sorting algorithm that sorts the elements by first grouping the individual digits of the same place value. Then sort the elements according to their increasing-decreasing order. It has worst case of time complexity of O(n plus k. Lastly, team sort is a hybrid stable sorting algorithm derived from merge sort and insertion, designed to perform well on many kinds of real-world data. Import team sort takes O and log n comparisons to sort an array of n elements. Now, we will summarize and analyze all sorting algorithms. Here's the big O notation for each sorting. This is the entire graph we put all the sorting we saw before. You can see bubble and insertion sorting noticeably. We can see here that even though the big O notation is the same, there is a large difference in speed depending on sorting. So, the graph that excluding bubble and insertion is as follows. It can be seen that shell and heap with big O notation of n log n take longer than radix and team, and quicksort is the fastest sorting. Conclusion. For each sorting, the time performance is as follows. The above figures may vary depending on the individual computer specifications and network environment. We can look up the output that we might see after learning the complexity of big O in our project. From the following research, we can conclude that the best algorithms to manage this problem sort in terms of learning time complexity are quicksort and team sort. Nurusaya made codes of bubble sort, heap sort, team sort, and team proposal. Dongyu made codes of insertion sort, radix sort, and final report. Yurin made code of quicksort and PowerPoint for presentation. Finally, Sang-jae Lee, made the code of shell sort and presentation. Thank you.